Okay, for the first set of problems on your review, you're asked to convert each of the following to rectangular form. So with rectangular form, that means you only have x and y values. So let's review some of the formulas that y'all were given in class. So the first one you were given was x equals r cosine theta. Another one, y equals r sine theta. You also were given x squared plus y squared equals r squared. Let's see, tangent theta. If I can get that theta right, that would be great. Tangent theta is y over x. And let's see, I think that's about it for these values. So up here, when we're going to rectangular form, that means that we want just your x and y values. That's all we're interested in, is an x and y value. So for this first one, r cosine theta, and this is a pretty straightforward substitution. That's going to be the value of x. So you have x equals -3. For part B, we don't have anything with just r, but we can square both sides and have r squared equals 5, and then we know r squared is x squared plus y squared. And so we can make that substitution for r, and we would be finished there. And the same over here on part C. We don't know anything about secant, but we do know secant is 1 over cosine theta. And then with some algebra, we can multiply both sides by cosine. So if we do that, notice the cosine thetas would cancel here. But over on this other side, I would have r cosine theta equals 1. And r cosine theta would be x. So our final answer would be x equals 1. All right, moving on to the next one. Part D would be worked the same way, except for the reciprocal of cosecant would be sine, so we would have r equals -2 over sine theta. And again, we can multiply both sides by sine, so we would have r sine theta equals -2, and so that tells me y equals -2. Okay, over on E, in this particular problem, you're going to have to change both sides. We know r squared is x squared plus y squared, and tangent is y over x. And for right now, just making those substitutions, we can leave our answers like that. So over here for F, we have r equals 10 sine theta. So let's see, r equals 10, and sine is going to be y over r. And so we can multiply both sides by r over y to get those to cancel. And over here, r over y. So here I would have r squared over y equals 10. And you know, r squared, we can change that part we know is x squared plus y squared. And we have that all over y equals 10. Now, if you wanted to move the y back up and over with the 10, you're welcome to, but it's not necessary. Okay, now for the next set, we're going to go the opposite direction. So we're going to change from our polar form, or change from our rectangular form back to polar. And we'll be using the same formulas. So for here, our x squared plus y squared, we know that's r squared equals 12. And taking the square root of both sides, we know r is the square root of 12. And we can reduce that radical. We can take out of 4, and the square root of 4 is 2. So we can have 2 square root of 3. All right, B part, we can go through. We know x is going to be r cosine theta, and that's going to be equal to -9. And again, we're just asked for polar form, so we can leave it like that. So r. Now, if you wanted to solve for r, some people do, now thinking about it, you can go ahead and rewrite this to be r equals negative 9 over cosine theta. You can also write it that way. Same is true for c. Again, going through your conversions, y, we know that is r sine theta, and that's equal to 3. And then if you want to solve for r, that's going to be 3 over sine theta. Okay, moving on to the next problems. Here, don't worry about getting so much into the problem. You can go ahead and make the change. X is r cosine theta, and it's quite okay just to leave it in this form. Minus 2 times y is r sine theta, and that's all squared, and then that's equal to 4, and you're welcome to stop there. Same is true for D. Again, y is r sine theta, and then that's going to be all squared, minus r cosine theta, and then that's equal to 5. And then finally for part D, again, we can make that substitution, and so we have r sine theta times r cosine theta, and that's going to be equal to 1. And it's perfectly okay to leave them in this form. All right, for the next part, you will need your unit circle for this. And this is where we did some converting. We put this back over to polar form. Now this first part, in part A, notice that we're given a complex number. And that complex number we had up on the board, and I'm going to write the formula down towards the bottom. You had a plus bi. That's your complex form. And so from here, we can go back through, though, and change this back over to our rectangular form here and here. Now, the form that we're given is r times cosine theta plus I sine theta. So that's the form we're given, but we're going to go back over to our complex number. So to do that, we need to evaluate cosine and sine of pi over 4. So we're going to have 6 times, and pi over 4 is root 2 over 2, plus root 2 over 2i. And then we can do our distributive property, and the 6 and 2 will cancel. So I have 3 root 2 plus 3i root 2. All right, moving on to B. Same idea again. So we do have root 6 times, and cosine of pi over 6, that's going to be root 3 over 2 plus 1/2 I. And now we go ahead and distribute through and multiply our root 6's. So we're going to have root 18 over 2 plus root 6 over 2i. I do realize that the root 18 will reduce, but it's really not necessary here. All right, and so for our next problem, we have 2 times cosine of 7 pi over 4. That's going to be a positive root 2 over 2. And then sine of 7 pi over 4 is going to be negative root 2 over 2i. And again, with your distributive property, we're going to end up with root 2 minus I square root of 2. All right, and again, that was changing back over to our complex number. Now we're going to change over to our polar form. So our polar form for this, that's going to be where our final answer needs to look something like what we have here. So we need to find r, and then we'll need to find theta. So the first part to find r, our formula, remember, is r squared equals, and we have x squared plus y squared. And then to find theta, we did inverse tangent. And again, these were all non-calculator, y over x. So you're going to need your unit circle for this. So if you don't have your unit circle, you need to get one before the 9 weeks exam. All right, so in this form, our a plus bi, we can really rewrite this to be 0 minus 5i. So the r part in this would be the square root of 0 squared plus 5 squared. So my r is 5, so I have 5 times. And now I need cosine of an angle plus sine of an angle. Well, cosine of what angle? So we have to go back and think about, well, the angle that we have in question here is going to be inverse tangent. So I have inverse tangent of, and again, we're going to have 5 over 0. Well, 5 over 0 is undefined. So where is tangent undefined? So let's go think about our unit circle values and think about around our ordered pairs. And so remember, it's y over x. So we really see that tangent's going to be undefined at either pi over 2 or 3 pi over 2. And so what's going to tell us which direction to go, we'll notice that our 5 is negative. So that means we need to move toward 3 pi over 2. So now we have our angle. And so we're going to go back and write this in the form. We're going to have cosine 3 pi over 2, and then plus I sine of pi over 2. Or 3 pi over 2, sorry. Then that's going to be our final answer. So continuing on here, it's the square root of 4. Well, we can go ahead and reduce that down pretty quick. We know that is 2. And so really I have 2 plus 0i sitting here. So again, the first part I need to know, well, what is my radius? So that's going to be 2 squared plus 0 squared. So my radius is 2. And then we need to find out our angle. So we're going to say tangent, inverse tangent, and our y over our x. So 0 over 2. So where would tangent be 0? Well, that's either going to be at 0 or over here at pi. And since our radius is positive, that means we have to go towards 0. So that means that we're talking about 0. So here we're going to have 2 times, and this is going to be cosine of 0 degrees plus I sine of 0 degrees. And that's going to be your final answer for that one. Okay, moving on to the next one. So we have negative 3 root 2 minus 3i root 2. So here, again, we're going to have to find our radius. We already have it in the form that we need. So the radius for this one, again, is going to be r equals the square root. Well, if I square negative 3, I get 9 times 2. So 9 times 2, that's going to be 18 plus another 18. So that looks like my radius is going to be the square root of 36, which is going to just be 6. So I have r. And now we have to figure out our angle. So inverse tangent. Now I would let these negatives tell me that I am in quadrant 3. So I'm down here in quadrant 3 somewhere. And then let's do our y value. So 3 root 2 over, and let's see, 3 root 2. Oh, well, that's going to be nice because that all gives me 1. And so over here, that's going to be 5 pi over 4. So now we're ready to fill in all of our values. So my radius again was 6. So I'm going to have 6 times cosine of 5 pi over 4 plus I sine 5 pi over 4. And that's going to be it for those. Okay, for the next set of problems, we are converting rectangular to polar, And this time it is not a complex number. It is just an ordered pair back over to polar. Now remember, with polar, that means we need a radius and we need an angle. We need a direction. So for the first part, to find our radius, again, that radius is going to be the square root of, well, negative 2 root 3 squared. That's going to give me 12, plus 2 squared is going to be 4. So that's going to give me a radius value of 4. Okay, and now for our angle, again, we're going to say inverse tangent of, and again, I'm going to ignore the signs because I know they're both negative, so we're going to be in quadrant 3, and so I'm just going to say 2 over 2 root 3, and so that means I have inverse tangent of 1 over root 3, and so if we are in the, and I'm going to move down here, if we are in the third quadrant, and we want angle down here, and we want 1 over root 3. So 1 over root 3, it seems like that might be 7 pi over 6, because we know our sine over cosine, and you also know your unit circle. So if you'll go around there, 7 pi over 6 should be our angle. So if we know what our angle is and we know what our radius, then we're ready to write our answer. So the radius that we found was 4, and our angle we found to be 7 pi over 6. Okay, moving on to the next. Again, the same process here. So to find our radius, it's going to be the square root of 9 plus 9. So our radius is the square root of 18. And again, you're welcome to leave it like that, or you can write 3 root 2. And then again, let's think about, well, what quadrant are we going to be in? Well, it seems like, let's see, x positive, y is negative, so that's going to be in the fourth quadrant. And we're going to talk about inverse tangent of 3 over 3. So we're going to talk about something over 4. So it seems like we would have, let's see, over here, what would that be? 7 pi over 4, wouldn't it? So here, again, we have root 18, comma, 7 pi over 4. All right, part C, 0, 1. So again, when we find our radius, I guess I need to get my pen to work. The radius is going to be the square root of 1, which is 1. And then back to inverse tangent. And really, if we plot this point, some of these, it might be just easier to plot them. Because if we're at 0, 1, well, we very quickly see that we're up here at pi over 2, aren't we? So we very quickly see that our coordinates here would be 1 for our radius and pi over 2 for our angle. And then part D was a typo. It should have been -1 here. And so if that's the case, again, we would have 1 comma, and then this one would be 3 pi over 2. All right, for part E, again, let's follow along the same process. So our radius is going to be the square root of 1 squared plus the square root of 3 squared. So it looks like our radius is 2. And then we might want to check, well, what quadrant are we going to be in? So it looks like we're going to be up here in the second quadrant. And so let's talk about inverse tangent of root 3 over -1. Well, +1, we've already taken care of the signs. We're in the second quadrant. So inverse tangent of root 3 over 1, well, that sounds like we're probably talking about something over 3. So in the second quadrant, that's going to be 2 pi over 3, isn't it? So here our radius is 2, and then the angle 2 pi over 3. Okay, for the final problem on this one, we would again start out by finding the radius. So we're going to have our radius as the square root. And let's see, so we're going to have 16 plus 16. So our radius is equal to the square root of 32. And then to find our angle, again, let's go consider, well, what quadrant would we be in? With both x and y negative, that's our third quadrant. And so when we do our inverse tangent, it's 4 over 4 or 1. So we're talking about something over 4, some pi over 4. And so that's going to give me 5 pi over 4 in the third quadrant. So our polar coordinates here would be the square root of 32, comma 5 pi over 4. And so hopefully, let's see, is that all of the problems there? Yep, moving on to the next. Right, now we're converting the polar coordinates back over to our rectangular coordinates. And this is where we needed a couple of formulas here. The first one, we had x is r cosine theta. And then the other one was y equals r sine theta. So for here, to find our x coordinate, we are plugging into our formula. So we have 4 cosine pi over 2. And so x is going to be equal to 0. And the reason why, let me write in that step. I shouldn't just go straight to the answer. It's going to be 4 times cosine of pi over 2 is 0. So that's why x is 0 for that one. And then we're going to follow through the same process here with y. It's going to be 4 sine pi over 2. And the sine of pi over 2 is going to be 1. So 4 times 1, which is 4. So the ordered pair that we found is going to be 0, comma 4. That's our rectangular version for this. All right, and we will follow the same process over here with the next set. So x is going to be negative 4 cosine of negative pi over 2. And so, again, this is still going to give us negative 4 times 0, which is going to generate 0. And then also, over here, we're going to have y equals negative 4 sine of negative pi over 2. And so that's going to give us negative 4 times negative 1, which is going to give us positive 4. So the ordered pair that we have here is 0, positive 4. Moving on to part C. Well, if our radius is 0, oops, I need to get my pen working. If my radius is 0, let's think about if we're plotting these and that radius is 0, then it doesn't matter what this angle measure is. I'm still stuck here with a radius measure of 0. And even if we looked at our formula, we would have x equals 0 times cosine of 270. And we would have y equals 0 times sine of 270. So at both rates, we would end up back at the origin, so at 0, 0. All right, moving on to part D. Hopefully y'all see how this is really just a lot of the same process over and over, plugging into your formulas. So here for part D, we have 5 times cosine of 5 pi over 6. And then we have, let's see, and let's go ahead and finish that. So that's going to be 5 times, let's see, 5 pi over 6 is in the third quadrant, so it's negative. And we're going to have root 3 over 2. And then we're going to go ahead and do the same for our y coordinate with sine. So we're going to have y equals 5 sine of 5 pi over 6. And so that's going to give me 5 times negative 1/2. And now we have enough information to write our ordered pair. We're going to have negative 5 root 3 over 2, comma negative 5 over 2. Okay, moving on to E. Again, same process. So x equals 5 times cosine of pi over 3. So that's going to be 5 times, let's see, 1/2. And then for the y, we're going to have 5 sine of pi over 3. So 5 times sine of pi over 3. So that's going to give me 5 times root 3 over 2. And so now we're ready for our ordered pair, which is going to be 5 halves, comma, 5 root 3 over 2. All right, and moving on to the last example, we have 4 pi over 3. And 4 pi over 3, we need to know that that is over in, 4 pi over 3 into the third quadrant. So we're going to have 4 cosine of 4 pi over 3. And so that means that we're going to have x equals 4 times negative 1/2. And so for y, again, working through, we're going to have y equals 4 sine of 4 pi over 3. And that's going to be 4 times negative root 3 over 2. And so when we put our answer together, we have negative 2 and then negative 2 root 3. Okay, our next part, we are graphing. So with our graphs, the first one we have 3, 0. Now, again, we do need to remember the whole idea of plotting our polar coordinates. Do you remember that this is not an x comma y so much as it's a radius and a direction? So let's see, whenever we're plotting these, so for A, 3, 0, so our angle is 0, so we need to go in the direction of 0, and then we need to go, a direction of 0 and then a radius of 3. So for 3, 0, we're going to have 1, 2, 3. So here we're going to have our point A. And do make sure you label your points. And then we have 4 pi. So we're going to go over 1, 2, 3, 4 in the direction of pi and label our point. And then 1 pi over 3. So again, that's going to be C. And let's see, now D is a little tricky because we know negative pi over 2 is toward 3 pi over 2, but then we have a negative radius of 2, so really that's going to throw us back up here, and so that's going to be our point D. And let's see, 0, our radius is 0, so on E, so that means we're not going anywhere, so that means we're still stuck at what we call the pole, and so that's going to be letter E. Negative 3 and pi over 2, so we do have our measure of 3 or pi over 2, but then I've got to go backwards 3. 1, 2, 3. So that's going to put F down here. Well, my pen has decided to quit working. 1, 2, 3. So we're down here. And so that's going to be F. And then G, 6, 0. So we're going toward the angle 0, and we're counting over 6. So let's see, 3, 4, 5, 6. So right here should be our final point, G. Okay, with our conic section portion, and you are able to use a calculator through here if you need to. Now, a couple of ways to very quickly identify some elements or some of these would be in part A. Notice how you just have an x squared. So that's going to be a great indicator that this is a parabola. Now for part B, notice here you've got different x and y values, and they're separated by a plus sign. So chances are this is going to end up being an ellipse. For part C, since both of these are starting with the same value, 12 and 12, this is going to be a circle. And then D, notice again we have different values, so that's going to mirror our part B, but the difference is we have a minus here, so that's going to be a hyperbola. And then notice that all of our factors here, they're just linear, so that's going to give me a line. Right, for the next part, we are given information here. Now, in order to pick out all of the different parts they have listed at the bottom, what we're going to do here is we need to do some rearranging because these values always had to be equal to a 1. So that means I need to divide each part of this by 36. And so before y'all put this in your calculators, you do need to get it in that standard form. So if I go through and I divide all of that by 36, then notice that the 9 is going to cancel with the 36, leaving a 4. So I'm going to have x minus 2 all squared over 4 plus y minus 3 all squared over 36. Oh, that 2 didn't write, so great. Over 2, and then that's all equal to 1. So what that's going to translate to graphically, and for our points, we need to find the center. Well, the center of this is going to be positive 2, 3. And again, you can use your calculators to verify that or your formulas, either one. Now for your vertices, we need to count our major axis from the center. Well, our major axis, that's just going to be the longer of the two. And so really that's going to generate here from 36. So if I take the square root of 36, that's going to give me 6. So that 6 is going to be a big part down here because your vertices, notice that 6 was under 3. So your vertices is going to be 2 comma, well 3 plus 6 is 9. And then the other is going to be 2 comma 3 minus 6 is negative 3. Our major axis, well that's going to be the distance between 9 and negative 3. And so let's see, if we look, that should give us 12 here. If we look at that total distance, now remember negatives aren't included in total distance. So if we travel from 9 all the way down to negative 3, we've traveled a length of 12. Now as far as the foci, let's go back up and see. We can find the foci. The foci, the formula for that y'all were given is going to be c squared equals a squared minus b squared. And again, your calculator will find this. A is going to be the larger amount. So we have c squared equals 36 minus 4, which is going to give me 32. So c is plus or minus, I forgot my equal sign, the square root of 32. Well, where in the world, what do we add that to? Well, the foci is on our longer axis or on the major axis. So we're going to add that to our y coordinate. So the foci here is going to be 2 comma 3 plus or minus square root of 32. And y'all can verify that in your calculators. All right, and as far as a sketch, again, y'all can sketch that from your calculators. All right, so for our next one, this looks like it's going to be a hyperbola. And so we're already in our standard form, other than you might want to change 36 to be 6 squared and 100 to be 10 squared. And so if we come down here and we look at our center is going to be negative 1, 4. And again, with the rest of this, you can verify with your calculators for the rest of those. All right, for our next ones, let's see, it looks like we have circles here. And for these, it might be quicker just to pick out your center from what we have here. So with the first one, our center looks like it's going to be a positive 2 and a negative 5. And our radius is going to be 8. And again, you all can sketch that from the calculators. And number 5, it looks like they were kind of being tricky, but that is still a circle because our denominators are the same. So our center for this one looks like it's going to be 0 and positive 2, and our radius is going to be 7. right? And so for our next set of problems, it looks like we're already in our standard form. And whenever you go to pick out that center, and again, we can use our calculators for here if we need to. Our center is going to be positive 2, and it looks like it's going to be negative 1. And our vertices, the larger denominator is under x. Square root of 49 is 7. So we're going to say 7 plus 2. And then we're going to say, let's see, 2 minus 7. So that's going to give us negative 5, negative 1. The length of our major axis, well, the distance from 9 all the way down to negative 5 is 14. And you can use your calculators to find the foci, or we can do what we did just a minute ago. C is going to be equal to the plus or minus square root of 49 minus 4, or 45. And so you would add that to wherever the larger amount was, which was under x. So the foci would be 2 plus or minus square root of 45, and then comma negative 1. Before you do number 7, this is going to be a hyperbola, and you do need to go ahead and get a positive 1 on this other side. So I'm going to go through and divide everything through by 100, and so that's going to generate our 125 will cancel, giving us 4. And again, our center for this one, we should be able to pick out is going to be negative 4, negative 1. And then all of the other information, I'd rather y'all use your calculators to pick out. Okay, for our next part, this is where we went through and we wrote these in standard form. We did complete the square, but we went through a little bit of a shorter method in completing the square. It's really the same idea. It was just made this a little bit shorter. And the first thing we did, we grouped our x values together. So we have x squared plus 16x. And then we have plus, and we're going to put in negative y squared. And then minus 20y. And then with that 18, we moved over to the other side. And then this is where we went ahead and said, okay, I know this is going to be x plus half of 16 all squared. And then over here we've got our negative, so I need to pull out that negative, and then that's going to make those positive. And we're going to say y plus 10, half of 20 all squared, equals, and then we have to balance this. So what did we add over on the left side? Well, we added 8 squared, and we also added a negative 100. And so we would have x plus 8 all squared minus y plus 10 all squared. And that's going to be equal to, well, let's see, that's going to be negative 36. And so, goodness, what is negative 36 and positive 18? Looks like that's going to generate for us, let's see, negative 18, is it? And then we can't have a negative or an 18 over here. So we're going to go through and we're going to divide everything by negative 18. And then we're going to be finished with this because that's going to give us a positive 1 on that side. We can also, just for grins, let's go ahead and cancel that negative and this negative. And so our final answer, and we can go ahead and clean this up a bit. Let's write our positive term first. So we're going to have y plus 10 all squared over 18 minus x plus 8 all squared over 18. And that's going to all be equal to 1. All right, so let's move on to part B. We'll follow the same process again. So here, let's see, let's group our x values together. So we have 8x squared plus 64x. And then we're going to say plus negative 4y squared plus 16y. And all of that's equal to 64. We do need to make sure we have a positive 1 before we start doing our shortcut. So I'm going to factor out an 8. And then I'm going to factor out a negative 4. So I have y squared minus 4y. And now we're going to go through and do our completing the square, and it will be our shortcut. So we're going to have 8 times x plus 4 all squared minus 4 times y minus 2 all squared. And that's going to be equal to 64 plus, that's going to be 16 times 8 over there. My goodness, that's a huge number. And then we're going to have minus, because we do have a negative here, minus, let's see, 4 times 4 are 16. So continuing on, we have 8 times x plus 4 all squared minus 4 times y minus 2 all squared. And over here, after you put together all that, you're going to get 176. And then getting close to the end, we will go back and divide everything by 176. And so once we do that, 8 goes into 176 22 times. So that's going to give me 22. 4 into 176 is going to be 44. And of course, all of that's going to give me 1. So my final answer here is going to be x plus 4 all over 2, or squared, all divided by 22, minus y minus 2. Oh, sorry, my kitty's trying to help us. Y minus 2 all squared all over 44, and that is equal to 1. And all of this awesome sauce right here is your final answer. Yes, there's going to be one like that on the test, so go ahead and work through it. All right, next problem. Let's swap colors. All right, and again, same process. Group your x's together. So 5x squared plus 30x. And then group our y's together. 3y squared minus 18y. And then throw 13 over to the other side. We do need to factor out a 5 out of the first parentheses. Factor out a 3 out of the second parentheses. And now we're ready to do our nice nifty shortcut. So that's going to be x plus 3 all squared plus 3 times y minus 3 all squared equals 13 plus, well, let's see, 3 squared times 5, 45, plus 3 squared, 27. And so let's see, if we add all of this together, let's see, we're going to have 40, 85 maybe is what that's going to be. 13 and 27, that's going to be 40. And 40 and 45, 85. So let's go ahead and divide each part by that 85. And all of this over here, once I divide that by 85, that's going to generate a 1. And let's see, 85 is not divisible by 3. So we're going to have to do some little fancy footwork here for this one. Now 5 goes into 85. It's going to go 17 times, so that's nice. This will not divide, so if it doesn't divide, we're still going to cancel it, but weird enough, we're going to put down in the denominator 85 over 3. I know that looks weird, but that's what it would have to be. So our final answer for this one, we can say, let's see. So we're going to have x plus 3 all squared over 17 plus y minus 3 all squared over 85 over 3. We do the reciprocal there, and all of that's equal to 1. And that would be your final answer. All right, one last problem for this. Let's go ahead and divide up our x's. So I'm going to have 4x squared plus 16x plus 4y squared minus 24y. and all of that's equal to 25. We are going to factor out a 4. So x squared plus 4x, and then plus, and again over here we would get y squared minus 6y. All of that's equal to 25. And now we're ready for our super duper shortcut. So we're going to have 4, and that my pen is starting to die. So 4 times, and that's going to be x plus 2 all squared, plus, and that's y minus 3 all squared, equals 25, plus, well, 2 squared is 4, 4 times 4 is 16, plus 9 times 4 is 36. So let's see, we have 36, 16, and 25. So that's going to give us a whopping 77. How strange is that? So once you add all this together, you're going to get 77. So let's go ahead and divide everything by 77. And again, we're going to have weirdness for our denominator, and that's okay. Don't discriminate against weird. They're numbers too. So we're going to have x plus 2 all squared over, and we need our reciprocal, so we're going to have 77 over 4 plus, and here y minus 3 all squared over, and again 77 over 4, and all of that is equal to 1. All right, moving on to the next part, and this is going to be our exponential equations. And so here, going through, we need to get our basis to be the same for these. And in order to do that, we see that we can make 27 to be 3 cubed. So we're going to have 3x minus 1 equals 3. And so we're going to have 3x equals 4. So x is 4/3. All right, moving on to the next. The cube root of 2, we need to rewrite that to be 2 to the 1/3 power. And 2 to the 5th is 32, and we still have x minus 3 here. So I'm going to have 1/3 equals 5x minus 15. And so here, if you want to get rid of the fraction, you can multiply everything through by 3. If you do that, you have 1 equals 15x minus 45. Add your 45 over, and then divide by 15. So we have 46 over 15 equals x. Moving on to the next problem. Here, our base is already okay. This is the same thing as 5 to the negative 2. So I have 2x minus 1 equals negative 2. 2x equals negative 1. So x is negative 1/2. All right, for our next set, again, looking at your bases, here we can make this 2 to the 3rd. So we're going to have 3 times 4x minus 1. And then this one's going to be 2 to the negative 5. So I have negative 5 times x plus 1. And so we have 12x minus 3 equals negative 5x minus 5. If we add our 5x over, we have 17x equals, and we add 3, we get negative 2. Let's see, this should be 2 to the negative 6. Oh no. So that's going to be negative 6. Let me go back and fix it. That's what I get for trying to rush through this. Alright, so let's go back and fix it. That's going to be to the negative 6 most days. I'm sorry, I must be running out of crack. So negative 6x minus 6. And if we bring that over, that's going to give me 18x, won't it? Yeah, equals negative 3. So x is going to be negative 3 over 18. If you feel froggy about reducing it, negative 1 over 6. All right, next problem. This is going to be 5 to the 1/4 power, and then this is 5 to the negative 3. So I have negative 3 times x plus 6. And so I have 1/4 equals negative 3x minus 18. And again, if you want to get rid of the fractions, you certainly can. You multiply everything through by 4. And so if we do that, we have 1 equals negative 12x minus 4 times 18, 72. And so if I add our 72 over, we have 73 equals negative 12x. And so we have 73 over negative 12 equals x. All right, and then for f, if all of the side becomes a 1, then this exponent must be equal to 0. And so solving this, x is going to be 9 over 17. Okay, for our next part, here we're simplifying, and notice we have an exponent here that's going to move to the front. So that's 1/5 times the natural log of e. The natural log of e is always equal to 1, so 1/5 times 1 is going to be 1/5. All right, moving on to part B, simplifying here. The shortcut that we did, we said this is log 3 to the second, and this is 3 to the third. So our answer is 3/2. Moving on to the next one. This one we have log, and 1/3 is 3 to the negative 1. 81 is 3 to the 4th, and so here we get negative 4. All right, and then our next one, part D, was a formula that we had. As long as this base and this base are the same, my answer is sitting right there. It's 57. All right, in our next problem here, log base 31 of 1. Anytime this value is 1, our whole entire logarithm value is 0, because this is saying 31 to what power gives me 1, and it has to be 0. And just like the previous problem, we see that the answer is sitting right here. We can move it to the front if you want to, so that's pi times natural log of e. And again, natural log of e is always 1. Pi times 1 is pi. Okay, moving on to the next set of problems. Now for these, this is where we could not get our bases to be the same. So we did the log of both sides. So for here, since I can't get 3 to be rewritten as 5, we said log of 3 raised to the 2x equals log 5. And then we're going to move our 2x down to the front. So I have 2x times log 3 equals log 5. And then from here, we're going to divide both sides by log 3. So 2x equals log 5 over log 3. And then our final thing to do would be to divide by 2. So if I divide by 2 over here, we could put it all over 2, or really we could just put 2 right there. That would divide it. So here is our final answer for that one. Same process over here. So here we're going to do log of both sides. So I have log of 1.02 raised to the x equals log 100. And you're welcome to change that to 2. This x value does move to the front. So that's going to be x times log 1.02 equals log of 100 is 2. Divide both sides by log of 1.2, so x equals 2 over log of 1.02. Okay, next problem, and this was going to be a condensing problem. So here, this side's already condensed. We can't separate this addition, so it's going to have to stay log base b of x plus 3 equals, now here we're separated with subtraction, so we condense that to log base b of 8 over 2. And the only way these two could possibly be equal to each other is if x plus 3 is equal to 8 over 2, which is 4, so x would have to be 1. All right, moving on to the next in part D. This is where we removed our log from the problem, and we said that we're going to have x raised to the second power So x squared is equal to negative 3x plus 28. We do need to move everything over to the other side to set up a factoring problem. And so here we have x plus 7 times x minus 4. And setting each part equal to 0, we get x equals negative 7, x equals positive 4. But if we plug negative 7 back in up here, we would get a negative base. So that gets thrown out. So my final answer is x equals 4. For part E, we would say 4 raised to the 0 power. Again, we're removing that logarithm. So 4 to the 0 power equals 2x. So 4 to the 0 power is 1 equals 2x. So solving for x, we see it has to be equal to 1/2. All right, next problem. Again, we do need to condense this together since it's separated by addition. And notice it's log base 3 plus log base 3. And it's not like the very first problem. So we have log base 3 of 6 times x plus 2. And all that's equal to 3. Now we're ready to remove the logarithm. So we're going to say 3 to the 3rd power equals 6 times x plus 2. So we have 27 equals 6x plus 12. And so we're going to subtract 12 over. So we have 15 equals 6x. So 15 over 6 equals x. And if you feel froggy, you're welcome to reduce that. All right, moving on to the next set. For this one, Mr. Pinion went over to Georgia to buy some scratch-offs, which is just another way of saying a lottery ticket. And so here our formula that we used for these problems, we had our final population, and we didn't use a subscript for that one, equals p sub 0 times 1 plus our rate raised to the time divided by n. And some of us, I think, forgot the formula. So he's going to win $12 million after taxes, and he will invest half of his money. We need to make sure we know half of 12 million would be 6 million. So if he invests 6 million, so we know that our initial population for this is going to be 6 million. So that means we need 6 zeros. And so we need to know that, let's see, he has an annual rate of 0.3%. So an annual rate of 0.3%. We drop the percent and move our decimal 2 places to the left. And the number of times that rate happens is annually. And our time is going to be 15. So we have everything we need for our formula. And so P is going to be equal to 6 million. He has $6 million. How great would that be? And that's going to be times 1 plus 0.003 raised to the 15 over 1, or 15. And there you can finish this by typing it in your calculators. All right, and so for question 5, Dr. Robinson enrolled in JSU in 1998. The cost of tuition in 1998 was $2,140. And so we have enough information to start writing in some initial values here. So her initial value was going to be $2,140. So we have $2,140. And I think we were given a rate here. What was our rate? The tuition increases at a 4% rate each year. So our rate, 4%, so that's 0.04. The number of times that happens is 1. And now we need to know T. So how much did it cost to attend JSU in 2010? So our total time here, well, from 98 to 2000 would be 2 years. And from 2000 to 2010, 10 more years. So that's a total of 12 years. So our final answer would be our setup, $2,140 times 1 plus 0.04 raised to the 12th. All right. And then in 2025, so the only difference for this problem would be our time. So our time is going from 12 years, let's see, so we're going to tack on another, how much longer? 15 years. So that's going to give us to the 27th, won't it? So here we're going to have 2,140 times 1 plus 0.04. And what did we say it would be to the 27th, wasn't it? And again, you can type that in your calculators to see what the answer should be. All right, and then question 6, our final question. The number of mosquitoes on a beach triples every year. Now, when we triple every year, that's going to change our rate a little bit. So let's look at our initial population is 2,500. So here we're going to have P sub 0 should be 2,500. Now our rate triples every year. That is a 2% rate of change. And let's see, that happens every year. And now we need to know, well, over what time period? So from 99 to 2005, that's going to be a total of 6 years. And so now we have everything we need to set up our problem. 2,500 times 1 plus 2 raised to the 6 over 1.